Hi students, in this lecture we are going to discuss components of smart electric grid. In previous lesson we discussed about what is smart infrastructure and what is smart communication. So now we are going to discuss smart management system and smart protection. So what are these two topics we are going to discuss in detail, mainly about smart protection and what are the challenges for smart protection, what are the measures to be taken for this. So these all components will be increase the performance of smart grid. So coming to smart management system, the main aim of smart management is energy efficiency improvement and operation cost reduction, demand and supply balance, emission control, and utility maximization. These are all the aims of smart management system. So coming to smart production system, so it is improve it what it have following factors to be considered, that is system reliability, failure protection mechanism, and security and privacy, information metering and measurement. In this, privacy in smart metering and security in monitoring and measurement. These all take cares to be taken by smart production system. So we are going to study in detail. System reliability means ability of a component to perform required function under stated condition for a stated period of time. So failure protection mechanism, it is to predict the weakening points or the residual stability existence in its energy subsystem. So failure protection mechanism with prediction and prevention means some research proposes to utilize PMU data to compute reason of stability existence. So major lockouts can be prevented by this. So failure of production mechanism is identification of fault and diagnosis it and recovery is possible by this, and microgrid protections. So microgrid, especially the protection required when it is isolated, is quite difficult because there is a power will be fault occurrence, there is a severe currents will be present, so it is a more challenging. So the second important challenge, how to provide segments to the microgrid, that is the second challenge. And security and policy issues. So cyber security is one of the biggest challenges of smart grid because vulnerabilities may allow attacker to penetrate a system. Mainly these hackers will hack the data in smart meters. So wide deployment of monitoring and measurement device could also go to cyber crimes will be happen. So coming to challenges, there are mainly five challenges: is interoperability between cryptographic system, conflict between privacy preservation and information accessibility, system complexity and expanded communication path, impact in energy consuming, and also cyber crimes and security. So barriers to smart grid technologies: huge amount of investment, market uncertainty, lack of regular framework, lack of infrastructure, technology immaturity, need of advanced bidirectional communication system in order to avoid the cyber problems. So for this, we are going to use two solutions, that is DA and TA, that is distribution automation and transmission automation. So here in this, we have studied about advanced meter infrastructures, AME. So it consists of utility DCCs. So in between AMI provided for communications, there will be consumer side we have smart meters. So DCC means data and control center, and MDMS is meter data management system. So AMR systems allow meters to read by utility personal over wireless links. So the smart meter measurement measures RMS voltage, RMS current, phase angle measurement, power factor, instantaneous active power, instantaneous reactive power, and energy consumption for every 5 minutes. Suppose times maybe every 15 minutes or every hour. So networking of AMI consists this. So meters are connected directly utility to MDMS, meter data management system. So vendor properly AMI solution is connected to data concentrated. It is a networking. This meter is connected to DCC by communication network. So meter is connected to directly to utility MDMS. Each meter communicates with MDMS or the communication network. This interface the broadband network to provide connectivity to the MDMS. So to end-to-end network, that is IP internet protocols. So each meter is IP addressable from the MDMS. So why vendor property AMI solution is required means AMI deployment is hindered at lack of cost, effective communication net further meter and AMI communication standards are only infancy. AMI deployment based on the vendor properties. So components of AMI means NAN, that is neighborhood area network. So the power line communication in RF frequency. So RF mesh is based on radio communication at frequency is 900 MHz. So PLC connected the secondary of the distribution transformer to the consumer as shown in figure. So next component is smart meters is important component. It supports the communication interface between NAN. The interface may be integrated with the meter or attached to meters from different meter vendor models. So this is smart meters and meter data concentrated collect this all the data and periodic measurements and alarm generated at the meters is sent by the MDM meter data management system to the meters and receives the corresponding responses from MDS and this will collect the data. So head-end means the head-end is AMI solutions to meter data management system. So head-end communicates with the meter concentrated over an internet protocol connection provided by the smart grid. So this is AMI infrastructure. Meter will be there, and there is a DCC router, and in between the communication network will be there. This is monitored by the MDMS meter data management system. This is smart protection. So by meeting all these things, we can protect the smart grid from false.